So I'm just checking.
Loud noise back there.
Yeah, it's kind of Guru Nanak birthday today, and there are crackers. People are burning crackers. So yeah, I think we are live, and so if anybody in the chat who is watching can let us know if you are able to hear us, so that we can just get started. That would be good. Yeah, I believe there are people watching. There are 7 people, 6, 7 people, I believe, already there who has joined.
Oh, I can see us on the YouTube stream. We are live.
Yes, the notification came to me as well. So those who have set the reminders, the notification should have gone to them. So hello everyone. Hope you are able to hear us. Yes, and we are getting the comments. Hi Rob. Hi Venkatesh. Hi Nitin. So we are live, and hello everyone. Welcome to the stream. And I'm Sayam Pathak, Director of Technical Evangelism at CIVO. And today I have a very special guest with me, who is, by far the best person on Twitter to follow as well. So I have Darren with me, and he's the co-founder and CTO at Rancher Labs. And so, Darren, you want to introduce a bit more?
Yeah, no, yeah, hello everyone. I'm excited to be here. I love talking about Kubernetes and all that stuff. I'm sure I'll say something stupid. Yeah, so I'm the co-founder and CTO at Rancher, and yeah, that's about it. I've created K3S and a bunch of other Rancher projects, and hopefully we'll talk about some of them today.
Yeah, so today's basic topic is Kubernetes distributions, and we'll talk about Fleet as well, which is also one of the Darren's creation. So it's pretty exciting, and I'm really excited for this. So I think we have enough folks who have joined, and we'll now get started. So first off, Kubernetes, as if anybody doesn't know, it's simple. It's orchestration tool to orchestrate the containers in a productionized manner. And today we'll be talking about Kubernetes distributions. Now, Darren, the first question that goes to you is, what is actually a Kubernetes distribution?
Well, goodness, I mean, I could talk like for an hour on this because I have I have a lot of opinions on what a distribution it's like what a distribution currently is, what I really think it should be, like where I think I mean, so it's hard to actually because there's not a very good definition of what a distribution is, and that's kind of something that came into play as K3S got accepted into CNCF, because K3S is the first distribution to go to CNCF, and it's kind of what is a distribution, does it belong there, and all those things. So it's like what I think what people currently view as a distribution of Kubernetes is the kind of the base components of a Kubernetes cluster, which is like the upstream components, which compose like the API server, controller manager, scheduler, kubelet, and kubeproxy. There's like 5 main components there. So that's kind of like the basis is like the upstream software is packaged in a way so you can deploy it. So there's the early distributions would be like COPS or KubeSpray or something like that, where you could just install those somewhere. But then you have to look at, there's also like the cloud distributions, the managed Kubernetes offerings, are those distributions or not? Or are they managed Kubernetes? So those are like EKS from Amazon or GKE from Google. And those, give you a little more than just the core software. It's also the whole runtime environment and managing it. So it's kind of hard to say what a distribution is right now, but most people kind of look at it as it's like it's the upstream packaging of, it's the packaging of the upstream components and some way to install it to get a running cluster. And there's a lot of them out there. I think there's a category in CNCF for distributions, and there's quite a few. Now,
there are a lot of distributions out there, and we have K3s as a distribution plus as a CNCF sandbox project that just
Yeah.
got recently got accepted, which is I think a great deal for the community, because now it becomes more stronger, and with the community power, it will be more adopted. So the thing is, when we think of a distributions, yes, in my opinion, we have all the upstream Kubernetes, which is there, like the K8s, and we have all the features of Kubernetes plus basically where we want to run it. So if you talk about GKE, so it's curated distribution that will be running on Google Cloud, where you will not be having access to some of the things like the master, and then you'll be given access to some of the features. But all in all, the kubectl commands and all the deployment services, ingress, etc., Kubernetes objects that you want to deploy, you can easily deploy over there. So when we say it's a certified Kubernetes distribution, what are the certain criteria that a distribution should match?
Yeah, I mean, right now to be certified, there's a process that you go through that is set forward by CNCF, which is basically you pass a set of conformance tests and then submit that you've passed those. And so there's a maintained set of tests that come out of the Kubernetes project that basically you just need to execute those and show that they all pass. We actually run that set of tests on every single PR for K3s. So like that's how we ensure that's compliant. So it's like, we don't merge if those don't pass. So that's, it's like every single commit to K3s, ensures that it passes. And then as part of the process, you just need to upload for every release, like 116, 117, 118, you just need to upload the results, or put in a PR to a repo. And so you can see all of them there. I can't remember off the top of my head where the repo is, but it's in the GitHub for CNCF.
Cool. So K3s, we all know that it started as kind of a side project. It was not the main aim that Rancher was, trying to
Before
build.
we go, I want to talk about a little bit more about like what a distribution is before we go
Okay.
deeper, because I have a lot of kind of opinions there, because it's like I think that the definition of a distribution today is just way too myopic. It's way too small, because if you look at what a Linux distribution is, a Linux distribution is basically the kernel plus a bunch of user space. So it's like Linux by itself, if you were just to install the Linux kernel, it's not super useful to an end user because you can't interact with it. You need a user space. So a Linux distribution, it comes with all these other components and a maintained set of software. So if you use that as like the analogy, you can see there's just getting the core Kubernetes, it's only so useful. And in fact, it's not very useful, a core Kubernetes. Like if I just go into like one of the kind of the upstream distribution would be kubeadm. So you can just run kubeadm yourself and you can install and get a cluster from Kubernetes, but it's not really complete. It doesn't, well, I mean, that's going very extreme, because the kubeadm, I guess, is technically not a distribution because it's just the installer, but like it's the basis of a lot of people's distribution is if you just run kubeadm, you don't even get networking. Like the cluster does not even really function. So in order to get like a baseline set of a functioning cluster, you need certain components. And it's like, is it possible? Can you bring up the K3s GitHub page, the README from our GitHub, because in there, or I guess I can. Let me see. Go to GitHub Rancher K3s, and all of this. We're in the process now of moving all the K3s repos over to a separate organization. So it'll be, I think, GitHub K3s-IO, and all the projects will live there. But if you keep going down, it talks about kind of like what a distribution is. But because, okay, so here's all the components, stop right there. So it's like where it says K3s bundles the following technologies. So you can see what kind of sets K3s apart from other distributions is that we wanted to make sure that like when you get a cluster, it's fully functioning. All the APIs work that you want out of the box. A lot of other distributions don't really do this. They kind of leave it up to the user. And so this is kind of one of the reasons why K3s is so popular. It's like everything just kind of works immediately. So you have the basics, like we include like the container runtime, the networking, core DNS metric server. That's pretty standard for all distributions. But then beyond that, we have an ingress controller. We have an implementation of a service load balancer that works anywhere. It's very basic, but the point is it does work out of the box. We have kuberouter for network policy. We actually kind of, pulled in some code from the kuberouter project, not the whole thing. We have Helm controller, which gives you a way to easily install Helm charts. Kine is the kind of the database backend thing. That's not super important. Well, it's a really cool technology. But then we have the local path provisioner, which gives you a storage class implementation. So you can see, like, just to get like the basic APIs that everyone expects, like ingress, service load balancer, storage classes, all these things, you have to install all those additional components. And a lot of like distributions of Kubernetes don't really do that. They just say like, well, okay, you provide so like we with K3S, we have a kind of a specific opinion. And so we've included those things. But like once you get, even like when you get to the basis of that, like that gives you a functioning cluster. Then you have all these questions of like, what's your monitoring, logging, all these other things, cert management. There's all these other components that are very popular in the ecosystem, a lot of CNCF projects that you have to install somehow. So it's like, to me, I really think a Kubernetes distribution really needs to extend much farther than what it currently is into a usable set of packages that includes kind of the user space stuff. That's not just, just the core thing. I don't know if that, the definition probably won't change because people kind of already have an expectation. Like, there's kind of a functioning definition right now of a Kubernetes distribution, but you can see like the analogy between a Linux distribution and a Kubernetes distribution is like, we have the exact same problem. It's like, once people get Kubernetes, is like, well, how do I install, where's like my apt-get install for everything else in the ecosystem? And those are things that, like, right now we are, tackling or doing all from like the rancher side, but I really like, it makes sense to me as part of the distribution, but we'll see how that goes. But anyway, so I just want to talk about, it's like, to me, I think people's view of what Kubernetes and the distribution is so small, because it's really like, when you look at like what K3S provides, most people are doing like that first 4 bullet points and like a runtime environment. So yeah.
Yeah, that's pretty cool. So when K3S got started as a side project, at what point did you realize that it's a go forward thing and we have to make it big? And how
Yeah.
many times have you changed the architecture?
Oh, goodness gracious. Well, okay. So, I mean, so people don't realize, it's like, it's kind of like one of those things where it's like, oh, it takes like, there's some famous thing for, it's like, it takes a long time to create like an overnight success. And so it's like K3S is very, it has, since it's been released, has been adopted and used. Like, the adoption has just been incredible. It's just amazed me how many people are using it. But what K3S goes back many, many years of me fooling around and tinkering with Kubernetes. And so the first inception of K3S came from a project called Rio, which that project, when it was first started, like the scope of that project was kind of like somewhat ridiculous. I started working on a project right after we released Rancher 2.0. And when we released Rancher 2.0, I was somewhat frustrated because I'm like, we created a great product. Rancher 2 has been great. It's been adopted. People seem to like it. But I just felt Kubernetes in general was just so hard to use. And so Rio started as just kind of this open-ended project of how do I make it easier? And so part of that was like, how to make it easier to spin up Kubernetes. And so at the time, I was focusing mostly on like the application user end side. And so it was like, well, how do I get the smallest, simplest Kubernetes so that I can just, deploy a workload, like I can get a deployment or whatever. So I actually took Kubernetes at that time and I just ripped out everything I didn't like about it. And so when I first put up K3S, I think like the tagline was something like Kubernetes without the stuff I don't care about. And I just deleted tons of code. I deleted like millions and millions of lines of code because there was just features where I'm like, I don't really care about that. I just want to be able to spin up workloads. And so when I started doing that, so I ended up building this tiny, simple way to start Kubernetes. But then I found as I was developing other things, I'm like, wow, this is really the easiest way to run Kubernetes outside of this project Rio. Like, so what I was doing is like, I would actually start up Rio just so I could get a Kubernetes cluster and use it. So I realized, I'm like, hey, this is actually a super simple way to just run Kubernetes. And so the first indication that that people might care about it was, I'm not exactly, I think I tweeted about it. It's like, I wonder if you can actually go, well, it's probably be hard to like go back to like version like 001. Is there a tag for like 001? You can see the README. It'd be kind of fun. There's going to be a lot of those tags, though. I think just put in the URL. Just change the URL so it has 0.00. Like, yeah, click on that and then change it to v0.0.1. That'll probably be the first release. No, it's not in there. Okay, but so the first indication I got is that anyone would care about it was, I think I just tweeted and I said, hey, something about the project, and it got picked up on Hacker News, and people were commenting on it, and a lot of people, like, they saw how easy it was to install, but I had ripped out so much stuff that I got all these requests of like, hey, this is really cool, but like I really want to use GPUs, or this is really cool, will it work with this technology or that technology? Is there, I wonder if it might not even be, is that 0.0.1.2? Try that one. Yeah, try clicking on that tag. But I bet you this is still, because we might have actually like switched the base of the repo. Because as you said, how many times have been re-architected? That's changed quite a bit.
Yeah, it's still loading.
Oh goodness, we broke GitHub. So it got up, like, so people saw like how easy it was to install, but they're like, hey, can I do this? Can I do that? And so just from like the interest that I got on just from Twitter and Hacker News of people, looking for some simple way to install Kubernetes, they it seemed like there was something there, but it was clear to me that what I had initially done was deleting a bunch of stuff was not the right way to go. It's like people inevitably are going to want every feature of Kubernetes. So I spent a good amount of time trying to figure out what, like, because when I first started, I just kind of randomly deleted a bunch of stuff and it made it smaller. But it was like, okay, well, what does it actually matter? Like, what needs to be deleted? And so did a lot of kind of research of like what actually impacts the memory footprint, what's the binary size, all these different things. And we basically kind of figured out with some like cool little tweaks and hacks and whatnot, we could actually get Kubernetes pretty small and not really drop any functionality. One of the biggest things that we remove in K3S is just the in-tree cloud providers and in-tree storage drivers. Yeah, those are the main two things. So it's like if you care about the in-tree storage drivers or the in-tree cloud providers, K3S is not going to work for you. Which if you're running in a a non-cloud environment like Edge or whatever, then those things don't matter to you. And if you are running in a cloud environment, there's a good chance there's an out-of-tree solution for you too. So a lot of people are running with like the out-of-tree, like DigitalOcean provider or VMware or AWS. There's out-of-tree providers for all those things, and there's CSI drivers for everything. So we given like basically we saw that there was some interest in this project. This coincided at the time with kind of some business things going on, which was a lot of people were coming to Rancher and they were asking, hey, can we run Kubernetes on the edge? Which, to be honest, I thought was kind of silly. It was like, this is really big and complicated. Why would you want to do that? Like, there's no way you're going to be able to get that to work. But when we created K3S and how easy it was to run K3S, we realized like it was a good overlap there of like, hey, K3S should be really good for edge projects. And so like that's how we announced K3S as this is Kubernetes for the edge. And, kind of just a little bit of that, marketing or putting it in that spin, it ended up getting adopted really quickly in edge, that it's somewhat like the de facto standard, approach right now for Kubernetes on the edge. And that area is just blowing up right now. But beyond like the edge stuff, K3S is huge within development, testing, CI, because it's just so simple to integrate into anything. That was a long-winded answer.
Yeah, but that was really good because we now, I mean, the people who are watching and who don't know about K3S, so now they know at least why it came into existence and where it is now. So it was generally available last KubeCon, I think, before last KubeCon went, the North America one, so 2019.
Yeah.
So it was GA then, and around that time, I believe. And since then, it has been, I mean, picked up huge adoption in across not only edge, I would say, but a lot of people are actually using it for their their actual running their workloads over there, because it's just plain Kubernetes. I mean, it's just running your workloads, and you can run it without any issues.
Yeah, and like and also you're from Civo Cloud. It's even been picked up, and people are running it in the cloud, which has been amazing. Because we actually, from day one, we're like, nah, we don't really care about we're not like really targeting cloud. Like, there's cloud distributions, but we found that there's a lot of use cases that still make sense where people want to run K3S in the cloud. And then we've actually been working, so Civo Cloud was the first one to offer K3S fully managed, and we're now working with a couple other cloud providers that are using it as their basis to offer cloud managed Kubernetes, because as a cloud provider, obviously you have to manage a bunch of Kubernetes instances, and since K3S is so simple, it's actually pretty easy to turn it into a managed cloud offering. And the technology behind the scene of how we do the data store stuff, Kine, makes it so you can really optimize this for shared environments, and there's a lot of really cool things people are doing to scale this really, really far. So ironically, even though K3 towards small scale, it actually scales very well. It's really easy. Like whenever we want to spin up like a cluster with like a couple thousand nodes, we actually just do it on K3S because it's so simple. It just kind of works out of the box. RDS, and you can scale it to until you run out of money, basically.
Yeah, I can actually show the audience. So I just have a bare instance. I just ran a simple curl command, and it's basically doing all the heavy lifting for you. So this particular instance do not have Docker. This particular instance do not have any command line tool. So it's plain CentOS box, and I just ran a simple command, and K3S should be up and running. Basically, a Kubernetes single node cluster should be up and running, within few seconds.
Yeah, and there's been a lot of work since we've kind of matured as a project or whatever. You can see we're actually now installing. This is on must be a CentOS box.
Yes.
We're now installing the components as RPM. Let me see, is we're actually just doing. So we're installing the container Linux policy because we actually support SE Linux now, which is really cool because this really lightweight, simple thing, and then it's also great security out of the box.
And you can see the one node master is already ready. So I mean, that's how quick and fast it is. Yes, Darren is right. Prior to the SE Linux one that you just saw when we were installing, so if you see these particular statements, the dependencies and this thing. So I think prior to this particular release, it was even more faster. And I think there are some security enhancements that have been done in order to support the SE Linux, and that takes a few more seconds to spin up a new K3S distribution.
Yeah, if you install on like a Debian base, like Ubuntu or whatever, it's going to be even faster because we don't install the SE Linux policy, because there's really no way for us to get the SE Linux policy in there except for with an RPM, because we need the upstream policy, and it's quite complicated, and way more complicated than I'd like it to be. But yeah, so it comes up real quick. But like the really cool thing is like, because if you were to run kubeadm, it's like, well, it takes a lot longer because that pulls and does a bunch of other things or whatever. It's a little harder or whatnot. But like, you don't actually get a fully functioning cluster. The cool thing about this is like, everything pretty much like all the standard APIs are going to work. So it's people. Which was really cool to me when we first like kind of announced K3S like larger, kind of did a more pushed out like a larger publicity thing or whatever, is I got so many people who are saying, hey, this is like the first time I was ever actually able to get Kubernetes running. like people were so excited that they're like, hey, I can just get Kubernetes running. Now I can like learn what a deployment is, or, so it was like, and I think that's why, it's been so successful, because even as much as we might talk about edge and there's like a huge business case there, the success of it is really much more people just running on their laptops or on a VM or whatever, because it just removes this huge barrier to adoption. It's like, I think when I had tweeted early about it, of just trying to figure out if there's interest, I'm like, hey, what if I made Kubernetes as easy to install as Docker Swarm? Like Docker Swarm is really easy to get up and running. So it's kind of like all the power of Kubernetes with all the ease of use of Swarm. And that was kind of like the initial, and you can actually see some of the, I literally took inspiration for some of the things that were done in Swarm, of like how you create multi-node clusters is follows very similar to how Swarm initially did it, which is creating a token and joining nodes with a token.
Yeah, so you can see this particular cluster comes pre-installed with traffic as an ingress controller, and you have your core DNS is there, metric servers is there, and you also have a local path provisioner. So it's basically a small but a complete package that will help you run your immediate workloads. So either it's for development, testing, or even for staging, and you can then have a multi-master and a kind of HA setup, and then you can run even the production workloads over there, which is extensive documentation is available how to set up a highly available K3S cluster as well, and there's a separate architecture diagram for that as well. And the cool thing about the latest release of K3S is that it comes now embedded with etcd. But if you go to the prior version, it's I think embedded SQLite.
So we have, so this has been like people have been confused a little bit about this, one of the biggest kind of changes that we did to Kubernetes. Well, we didn't actually have to modify upstream Kubernetes, but one of the biggest things that we do is by default K3S runs on SQLite, and that keeps it really lightweight, less CPU, less memory, less kind of IOPS and everything. So for a single node cluster, SQLite is really good. But if you want to run HA, then SQLite is not good because it's just a single node. So that's where we now embed etcd. So SQLite is still the default backend, but if you want to run an HA cluster, and the commands are slightly different, it's still very easy to set up an HA cluster. It will use etcd under the hood, and it's embedded into the same process, and it's really cool. I mean, it's like I'm amazed at how slick the team made this work, that etcd, because kind of our history of doing Kubernetes and stuff like that, etcd has always been the most difficult part of Kubernetes. It's not that etcd is terrible or anything. It's a persistent system. It's a quorum based system. You need to know what happens if you lose quorum, like how do you recover nodes. Like there's just all these things you need to worry about it, and we just made it pretty much just seamless. You can just start a node, join, you run server. If you can do help on the server command there, you can. Yeah, so you can see these. Go down where it says cluster. So basically, there's this cluster init, like a cluster reset, cluster init. Basically, if you pass the cluster init, it will initialize a new cluster for an HA, and then you just need to run the agents or run the server and then just join using the token. But it's just a couple commands. It's in the docs and everything. But we actually do it like so. When you bring up a node, you add a new node in. It joins in the node as a follow, or sorry, what is it called? Like a listener. Oh man, I forgot the term. What is it? Um, a learner. It joins it will join in as a learner, because if you don't join in as a learner, what happens is you add a new node into the cluster, and it has to learn the state and then come up. But while it's learning the state, it's kind of everything kind of will freeze to a certain degree because it's trying to replicate the state across. So it comes in as a learner, it learns the state of the cluster, and then it'll automatically switch it to being a full member of the cluster, like an actual participating member. So the whole, it's like we kind of just manage that all magically for you. And then if you want to if you delete to like remove a node from the cluster, is just the kubectl delete node, and that pulls it out. And like everything's just kind of done for you under the hood. So it's pretty slick.
Yeah, this is pretty interesting. But we also have embedded as etcd as a single node K3s binary, right? If we
Yeah.
have the latest release.
Yeah. So by default, it is still SQLite, because there are the downsides of etcd is it uses more memory, it's more intensive on the disk, and so these things don't make sense for because K3s is still used in a lot of single node deployments. Like so it doesn't make sense to add that, to make that by default. And we do have that in the K3s docs. There's some kind of profiling information of how much memory etcd will add, how much CPU. So you will see that when you enable etcd, the CPU and memory and disk IOPS are going to go up.
Yeah, and this is the I think the core behind all the backend database that actually made it possible for having different databases for backend database options for K3s. Am I right?
Yeah, and so this is the Kine project. Kine, it stands for Kine is not etcd. In the history of what are those recursive acronyms in the Unix world. So what Kine is this is actually, so like K3s, goodness, I think it's been around for maybe 2 years now, but Kine actually, like the origin of this project goes back probably about almost like 5 years or something, 4 or 5 years. Go to GitHub Rancher etcdb. So I'll show you. This is where this project actually started. Everything we do at Rancher is like open source and available, and so you can kind of see, a bunch of failed ideas and failed projects and whatnot. And so this one was the last commit on that. What year? I can't read that.
5 years.
5 years, yeah. Okay, so this was so this actually goes back. So when we started working with Kubernetes, like as I said, the biggest problem we had was running etcd. Was just so the thing is running any persistent system requires a certain level of expertise, and it, you have to build up kind of tooling and stuff. And in the beginning, etcd was extremely immature. I mean, at that point, 5 years ago, it was actually not stable. It's very stable now, but at the time, it was like we had switched over from this orchestrator we had written in-house called Cattle, and then we moved to Kubernetes. And when we were running on Cattle, it ran on a traditional database. And all of our users didn't really have much problem with that, because the reality is most people can just either have expertise with like MySQL or some traditional database, like they already have expertise in-house, or they can just buy it as a service. Because everyone offers, a MySQL or, MariaDB service. So we started with Kubernetes, and we're like, hey, it'd be really nice if we could run Kubernetes on top of a database. And so we actually started this project 5 years back, and we had worked with Glider Labs. They actually did that work. We didn't continue forward with that project because we realized the maintenance overhead. The timing was bad because this was before etcd v3 was coming out, and this was based on etcd v2. But it was like basically this was the initial idea of like, can we effectively emulate etcd on top of a traditional database? And so this project didn't go anywhere, but then I created another project that was called KVSQL. You can probably find that one somewhere in there too. It'd be Rancher KVSQL. I can't see. Is it? It might be an I build the cloud actually. Yeah, there we go. It's in my personal one. So then this was the next version of this, and this was what I did here was I actually forked Kubernetes and wrote a proper storage backend to Kubernetes that that directly went to a database. And so this was what was actually in the very first version of K3S, was this KVSQL. So the big problem we ran into with this was it was pretty much an impossible thing to upstream. We wouldn't be able to upstream it because there was already kind of some pushback from upstream that they didn't want to accept another storage backend. And the kind of the official answer was, if you want a different storage backend, you should probably just write an etcd shim, which is, implement the etcd API and then whatever. And so so we scrapped that, we rewrote this again, and that's what kine became. And so kine it actually runs as a standalone component. It requires no change to Kubernetes. It just exposes an etcd API. It is a very not usable API. It is not like you can't just use this as a replacement for etcd. The API, it only exposes exactly what Kubernetes is looking for, and it exposes it in a way of how Kubernetes consumes the API. So it's completely not usable as a standalone etcd thing, but it works perfectly with Kubernetes. And so, we have very deep knowledge of how, the Kubernetes interfaces with etcd and stuff. So we created this component. And so now the way this runs is really cool in that it is not tied to K3S. It does not require to modify Kubernetes. Anybody can pick up Kine and run it with a Kubernetes distribution and have it talk to MySQL or Postgres, DQ-Lite. This is what, so MicroK8s is a distribution from Canonical. They're running Kine with DQ-Lite for their backend.
I have two questions for that, which are ready already, but I will park them for now. Just wanted to ask, we have K3S, and I can kubectl run nginx hyphen image, and I can run
Give a
pod.
0 on the front there.
Oh, so I can run a pod as well. So that is fine. So what happens when some issues come? Because this is now running as a single binary, and you have a master process, and then on the agent node, if there is, then there's an agent process. So how you debug when issue comes? What are those some of the sites that you can give?
Yeah, so typically it's looking at the so there's two levels of debugging. There's one is just because most people's debugging is Kubernetes is a very stable component at this point. So most people, when they're debugging Kubernetes, it's really looking at the Kubernetes objects. That's what they, you can get pretty much 98%. But if you need to go a step further, there's a couple things. One, the logs. This is just running as a systemd unit. So you're going to get the logs in the journal. So you can just do, journal ctl -uk3s. You'll see the logs. It's very hard to interpret any output for Kubernetes. So this is typically, to be honest, not super useful. But so that's one thing you can do. The other thing is, if you want to look at the lower level container runtime, which we package containerd, there's two commands available to you. There's CRI-CTL and CTR. Those are two tools to look at the container runtime. CRI-CTL is much easier in my mind. Like this one is, you can just run like PS. It'll show you what the running containers are, and it gives a pod-centric view. So it's going to tell you the container and then what's the pod ID and the let me see. Yeah, and then the names of those, let's see, do they correspond? They should correspond, I believe, to the container names. Yeah. So, and then you can do like exec and attach and logs. And so you can see like what are the running pods. There's even a lower level tool, which talks directly to containerd, which is the CTR command. That one in my mind is a little harder to understand. So this one, you can do CTR task list or container. So if you do task Yeah, so this is going to give you all the, but this one's fairly low level. Most people, you have a little more success with a CRI CTL because, so if you're not familiar with these technologies, it's like, so the way Kubernetes communicates to the container runtime is through an interface called CRI, Container Runtime Interface, and so CRI CTL is a tool which interacts directly with CRI, so you get the Kubernetes view of the runtime, and then the next level below that is the CTR, which is talking directly to container D. So CTR would be kind of the equivalent of like the Docker command. It's just that container D is pretty low level, and it's a little abstract in my mind for people to understand. So if you want to debug the actual container levels, I would say start with the CRI CTL.
Yeah, so why I wanted to bring this up is so that the community knows that K3s binary doesn't only ship with all the Kubernetes components. It also has these debugging tools which I have not pre-installed. So they come with K3s itself. So you have the CRI, CTL, and CTR tools embedded in the K3s binary itself. So you can do the same level of debugging. CRI, CTL is kind of same with like Docker PS and all those commands. The only thing that you can't do is you can't build the image using K3s, for which there is a separate project, K3C, which can
Yeah.
help you actually building the containers, building the images from the Docker files that you have, that you can do using the K3C. And there was a plan in past that I have heard, like K3C will be replacing the container D part, and
Yeah.
you'll
So
see over
I
there.
can I can talk a little bit about the K3C. I want to point out one thing. I'll talk about K3C in a second, but I want to point out one thing, just kind of like the magic. There's so much going on with K3S that people don't realize how much effort has been put into how this is packaged and everything. Go into var lib rancher K3S, that directory. And then just list there. Then go into data. And then there should be some random hash. Go into that random hash. Okay, and then just list there. Or just do find, I guess. Just type find. They'll list everything that's in there. Okay, so and scroll up, like, because that's just so you know strong swan stuff. Keep going up. Yeah. Okay. So K3S actually has zero dependency on the OS. Like you can literally run this in pretty much just as long as you like, because literally if you just had a kernel that set up the C groups and the like dev proc sys, like if you booted Linux and just set up dev proc sys, you could then just call K3S binary. We have zero dependency on the host OS. We include an entire BusyBox runtime in there to make sure we have all the utilities and all the commands that are needed for. There's a bunch of, since this is BusyBox, there's a bunch of extra ones you don't need. Those are just all symlinks to BusyBox, but we include everything that you need from the user space dependencies. These are things like IP tables, SOCAT, ETH tool, a bunch of random things. And then on top of it, we even support like IP tables versus NF tables, which is a big disaster and very complicated. It's like we take care of all this stuff for you. On top of it, we also have support for encrypted network out of the box, either through WireGuard or so at the time WireGuard was not as mature as it is when we first started K3S, and so we have IPsec. You can do an IPsec encrypted network, so you can see Strong Swan is actually included in there too. To be honest, I kind of hope to drop that and just go straight to WireGuard, because that WireGuard's like, but we also have support for WireGuard. It's just we don't include the WireGuard runtime. You have to install that yourself, but you can do WireGuard. So you can do encrypted networking out of the box with K3S really easily. There's documentation on that. So it's like, I mean, it's like there's so much stuff that's packaged in K3S and this little like 50, 60 megabyte binary that people, don't realize. And so this is also, it's like, there's just all these little things that like we've done to just make it work seamlessly out of the box. You know, it's like the fact that K3S runs so easily on a Raspberry Pi, that's very difficult to maintain. I mean, it's been very, very difficult. Like ARM v7, the 32-bit ARM support, we put a lot of effort into ensuring that works, because basically every single version of Kubernetes seems to break it in some new creative way. So there's like little things in patches and stuff that we maintain to make that work. So anyway, so I just wanted to point that out, all that stuff that's in there.
Yeah, this is really amazing because this is very important because people who are watching and they want real insights. So this particular K3s is shipping with a lot of things that you can do. That's why I wanted to bring that debugging perspective over here. So it's not just that you can run your workloads; you can actually see, you can debug them at just easy as you can, and without even you having to install any of those things. So you just got the K3s binary and then it's done. So you can just run the workloads and just debug them and use all the utilities that come as part of it. So that's the beauty
Yeah,
of it. 50, I mean it's around 50 MB binary, so it's pretty light. So that's what we call a lightweight. And this particular repo that I'm showing, this is actually what Darren talked about, running it on K3s on Edge on Raspberry Pi. So if anybody wants to try it out, so this is already there. So this works readily on Raspberry Pi and having influx on top of it and bunch of other stuff. So I presented that and on the KubeCon. If you are interested, you
yeah.
can readily
And,
run that.
and if you're interested in, Raspberry Kubernetes on Raspberry Pi, Alex Ellis, he's kind of the master here. He's got so much good content around
Yeah,
that. He has a tool called Ketchup. It's spelled K3S UP, like K3S
UP.
up. Yeah, but so that's Ketchup. Makes it really easy to deploy Kubernetes onto a bunch of nodes. And another tool called Arcade to install a bunch of utilities or install a bunch of
Apps.
tools and apps, and so a lot of he's got a bunch of amazing content. So definitely check him out. Follow him on Twitter. Um, but going back to K3C, so I want to talk about K3C because this is a project that we put that out there early. I think it was like earlier this year. I don't wait. Yeah, I think so. Like it's time is weird these days, but K3C was there's a big gap right now within the Kubernetes world of like when you look at container development, like how do you build and run containers? Is that the commands like Docker build, push, pull, tag, run, like those kind of basic things you need to do to create a container don't really exist in the Kubernetes world. So you kind of still need to install Docker first, and you run Docker on your laptop and you build containers and whatnot, and then you move over to Kubernetes. And so the idea of K3C was how do we bridge that gap? And so I don't particularly so we announced this and we kind of ran with this for a while. I don't really like the architecture of what we did. So we're going to re-architect this because the way K3C is architected as it was as a component below K3S. And that's kind of a little confusing and it doesn't really make sense. Like there's a bunch of little technical oddities about that or whatever. It didn't seem to work out really well. So what we're going to do is we're now in the process. So Jacob is kind of the main engineer behind K3C. He's in the process of re-architecting this to basically make K3C sit as more of a project next to K3S as a companion to it. So you can install K3S and then run K3C, and then it will augment K3S and add the image building capabilities like push, pull, tag, and all those things on top of it. And so you'll then get the container development experience with K3S. Because that's what K3S is purely just really the runtime right now. As I said, if you want to really develop containers, build like Docker files and stuff like that, you still really need Docker today. And so K3C is going to close that gap. And then we'll see. We might even rename the project. I'm not sure because it's like, but we'll see. So it's like I'm really excited about this one because for a while, we've lacked that basic thing of like, well, people get K3S, but how do you build a Docker image?
Yeah, I was actually seeing the repo, and so we gave a talk on this all day DevOps on all this K3C, K3D, K3S. So it's pretty amazing. So Rancher actually loves K-S, so they'll be
Yeah,
filling.
yeah. We were like yeah. There was another project that was called K3V. This is a project that I loved, but it was just far too advanced for people at the time, which was effectively virtualizing Kubernetes clusters. So you could have one large. So you'll find it in I Build the Cloud. So Yeah, virtual Kubernetes. This was a project that I loved, and so basically this is just a quick proof of concept to put together where it's like you can take a large cluster and then you can chop it up into virtual clusters, and so then you can give people access to a basically give them like full cluster admin access to the virtual Kubernetes, but it's running on top of an underlying Kubernetes, which is then fully restricted. So from an infrastructure team, you could build a large Kubernetes and then just chop it up and give it. So it was this really cool separation of responsibilities where it's like the infrastructure team just has to be able to provide like the core resources, storage, networking, and pods in a very secure way, very locked down. And then people could install virtual Kubernetes on top of it and then get the full access to Kubernetes power of CRDs and all that stuff and do whatever they want. But from a multi-tenancy perspective and stuff like that, it's super secure. So this was a proof of concept at the time. Oh shoot, I can't remember who. It might have been Alibaba. I can't remember exactly which company. They also started a project within Kubernetes called, I think it might be called Virtual Kubernetes. They started a project upstream to do this in a slightly different architecture, and so I'm really excited now because Apple, they had. I think Elena from Apple had talked about a lot of this stuff, how they're leveraging that, and so there's a lot of work now I know at Apple to continue forward with that because it like perfectly matches their needs of what they're doing. And then on top of it, there's another startup out there, Loft. It's their website, I think it's loft.sh. They've kind of the architecture of what they did is very similar. Like it was more of the style of how K3V worked. It's all their work. They didn't, they built it all from scratch or whatever, but the architecture was a little closer to how I did K3V. And so these two projects I think are really exciting. This idea of virtual Kubernetes, because I think as Kubernetes expands, we're going to see this become, this might become a thing because it makes sense for large organizations, because the reality is sorry, this is going way off on a tangent or whatever, but like the reality is multi-tenancy is just super hard. It is super hard to run multi-tenant clusters and to do it securely. And it's really questionable of whether or not it's even worth it in my mind, because it requires so much effort to run multi-tenancy, and the main thing you're getting out of it is the better resource utilization, but the better resource utilization, that even has issues. So the current model of large multi-tenant clusters, I think, is fairly flawed. And so if people want to do large multi-tenant clusters, I think the virtual Kubernetes approach is actually a lot more reasonable, but it's going to take some time for people to mature and see kind of like the value there. But anyways, so that's something.
There are the organizations who want to spin up with basically Kubernetes in Kubernetes. So people have talked a lot about this, and there have been POCs, and people have been using it. KubeVirt is there, so a lot of projects, interesting projects are out there which helps you do that. So I think this will be gaining a lot of maturity. So we have covered till now K3S and like all the aspects of it, and we have actually installed it, so for a small demo and how to debug that as well. So this particular session is Kubernetes distributions. Now we have talked about K3S, which is your own child, and everything about it. So now, what are your opinions on the other Kubernetes distributions? So specifically two that I want to touch, which is MicroK8s and the very recent one by Mirantis K0S.
These are interesting projects or whatever. So MicroK8s has been around for a while. MicroK8s was there before, I believe, K3S. And so MicroK8s was kind of the main thing about MicroK8s is that it's installed through Snap. So anywhere that you can get Snap running, you can get MicroK8s running. And so it's a very lightweight installation, and they have like the user experience. It's really quite slick. I actually tried to make this my go-to kind of the kind of like my go-to development environment for a while, I ran into like issues. It's mostly has to do with Snap, of just like the isolation of how Snap isolates things from the host. Was like there was just a little differences that got to be a little annoying, and then I had to basically go back to Minikube at the time. But so MicroK8s initially was geared just towards development, and it was single node, and so and it was pretty slick the way they had done it, and kind of like the difference of like when we created K3S, when we first announced that, was that we didn't want, like, there's a lot of distributions that are very similar to MicroK8s, which were like single node, geared towards development, quick spin up or whatever. And with K3S, we didn't want to target development. But I mean, it ends up being used there a lot. Was like we wanted to create something we could run in production. And so that was always the goal with K3S, was we wanted production multi-node clusters out of the box, fully conformant and everything. So MicroK8s has since kind of changed their focus towards doing multi-node, and they do multi-node with DQ Lite. DQ Lite is their own implementation of Raft on top of SQLite, and so then they're leveraging Kine also to do that. So they have their own implementation of that, and so they more recently kind of switched to production. So the kind of the biggest problem really with MicroK8s, in my view, is that the shift from being single node development to multi-node production was that it kind of already set like the precedent of like what people were kind of what bucket they put it into. So people didn't really initially give a lot of attention to MicroK8s, and so it didn't. It's really cool in development, but it didn't get adopted in a production use case. And now it's targeted a lot towards edge, but it's not getting adopted as fast, and I think a lot of that also has to do with the fact that it's using Snap. You need Snap on top of, it's like, so it's the adoption has not been anywhere near the same as K3S, and so it's an interesting project, but I think that when people use it, you'll see like there's a little like. There's a little more, as much as they try to make it really simple, there's kind of a little bit more barriers to using it than needs to be. But wish them the best of luck or whatever.
Yeah, I think when I started, using MicroK8s was after this blog came. So this blog is not very old. So that they recently announced the high availability, and like you said, K3S was never built for a developer purpose, so it was built for production. So that was always the first approach, like we have to build something for production, which I think have led to a lot of adoption, because people know like when now they are using in development, and that same thing they will use in production. So that gives more confidence and more usability, so people gradually adopt to such things. And yes, the Snap thing is another drawback. But yes, they have HA, and it's very interesting article how they have mentioned how they will be achieving HA. So have a read about it. It's interesting, and check it out. Now the recent one, which is I don't know where did I choose that? Okay, let me do it again. K0S, which was just launched by Mirantis, and it really uses Kine for the rank Kine, and they are. So, what are your thoughts on this?
Yeah, this was a funny project because, the name K0S is very close to K3S, and then if you look at like all of the things of like how it's packaged, the features it has, everything. I mean, it's so close to K3S. Like, there's so many like, so it's kind of weird because it's like, it's so close to K3S, but there's no mention of K3S anywhere. Like in any of the documentation, the publicity, the articles that came out, I think like, New Stack and stuff like that. Cause I had tweeted which in the New Stack article, I was like, there's plenty of other micro distributions. Like the first one that comes to mind is MicroK8s. And it's like, really? You didn't think of K3S? But anyways, so I look at this project and I think it's really, it's very flattering from the perspective that like K3S actually, like the fact that we use kine and like we did a lot of little things that were quite different at the time. And so to see a new distribution come on the scene and then, follow a lot of the same approaches that like, effectively adopt some of the similar decisions and design points or whatever, is really quite cool. So it's neat to see, that they're doing this. So, and I actually understand why you would create something like K0S, and because like the big difference, that they're really touting here is the idea of its vanilla upstream Kubernetes. And it's not like, so with K3S, the whole idea of K3S is that it's lightweight and it's geared towards resource constrained environments. And as a result of that, we chose components that are more geared, like we embed a lot of components, and like a lot of our decisions of how it works out of the box is geared towards that. So if you're looking at like a enterprise grade data center type installation, the choices that we made for K3S don't necessarily make sense. So the flip side is we have a project which is very similar to K0S, which is called RKE2. And so I can understand why they created K0S, because it's probably for a lot of the similar reasons why we created this other project called RKE2 from Rancher. And so what RKE2 is we took the user experience and the core kind of bootstrapping technology of K3S, but instead of running embedded components, we run vanilla upstream static pods the same way you would in kubeadm. And so what you do is you get an installation that it takes a lot longer to start up. It takes a lot more memory, but it's running completely vanilla components in static pods. Things like, Calico, or we're not now, right now we're still, I think, believe we're defaulting to Flannel plus Felix. But you get like the Nginx ingress controller and stuff like that. So anyway, so the project we have, RKE2, is very similar to K0S, and so I can understand why they created this. And so we'll see where they go with it, and I think it's really interesting.
Yeah, I mean, yes, it's interesting. I wrote an article about it as well. Like, basically, I wanted to compare K3S, K0S directly with K3S because the name sounds familiar. They are using Kine. They're using the products that already K3S is using. Now we have Kubernetes distributions, and we have K3S, and now K0S, and now someone might create K negative S or something like that.
Yeah.
But the question here is, how difficult it is to contribute to upstream vanilla Kubernetes and not create a distribution, or versus creating a distribution and because you cannot do the upstream contributions, or there is just a slight change that you want and you create a new distribution. So what is that?
Well, no, I mean, so K3S is quite different in that we're I mean, really, I can't think of really any other distribution that actually modifies Kubernetes. Like, we actually modify Kubernetes. We maintain a series of patches. It's very small. It's like less than 100 or less than like 1,000 lines of code. It's very small what we do. But most distributions are just packaging pure upstream Kubernetes. So they to create a distribution does not require you really to change Kubernetes. So it's like you wouldn't create a distribution because you can't get things done upstream. But it is definitely, difficult, or not difficult. It's a slow moving process to get things upstream, and for good reason. I appreciate kind of the process and what happens upstream, and it's a difficult task there. So that's not kind of like a deciding factor of creating a distribution. So the distribution is more. That's why it's kind of weird, because it's like before K3S, most distributions are just they're really just glorified installers. Like, it's just how do you install Kubernetes, and so what differentiated them is the provisioning technology, not what you get at the end. K3S is quite different in that it's really two different things. As one is we completely removed the need for provisioning because it is just a binary you run. So there is no provisioning technology included in it. And then what you get at the end of the day is more than what other distributions was. So it's quite different. So if you go from the other perspective of it's like mostly provisioning technology, it's like, well, why would you create another distribution? It's like, well, because you had a new way to install it. But what we're trying to prove with K3S, and I think we've done a decent job, and K0S follows that, and RKE2 follows that, is that we can effectively remove most of the complexities of how you provision this thing. The approaches that we've come up with or whatever, it makes it almost like zero provision. It's just copy a binary, start it with the proper configuration. That's it.
Yeah. So K3S, you have mentioned, and we all know it's production ready. And Kubernetes itself is, yes, it's production ready. So what, I mean, for maybe, let's say if you're a small startup, and so basically I want to make the community understand when now you should be using a full Kubernetes versus not using K3S. So what all things you won't be able to do, like the entry cloud providers are there, and you have the storage.
Yeah. Well, yeah. So the first thing I'd actually say is if you're a startup, you're a small development team, seriously question why you're even looking at Kubernetes. Is Kubernetes, it's an amazing platform, but it comes with a certain learning curve and everything like that. So don't start off with like, we're going to run our own Kubernetes clusters and everything, because you're going to spend so much time just learning Kubernetes and how to, so it's like focused on your application and build something up higher up the stack. It's like what Kubernetes is accomplishing is amazing. This technology is definitely not going anywhere. It has huge applicability for a lot of use cases and whatnot. But if you're just like your focus is just like writing an application and deploying it, yeah, I would say kind of start somewhere else. But if you are running Kubernetes, so I think the cloud distributions are the way to go. So it's like, like Civo Cloud, is amazingly simple. DigitalOcean is also amazingly simple. So with a couple like clicks or whatever, you can get a distribution of Kubernetes running. So it's like, I highly, highly, highly recommend people, if you're getting into Kubernetes now and you have a reason to be using it and you want to run it in production, just go with the cloud distribution. EKS, GKE, AKS, all of them are very decent. I mean, I think EKS is the one that is by far the most complicated one. Unfortunately, like the big, kind of the biggest, most popular cloud is also the most complicated one. But so if you can start with one of the other ones and then maybe move theirs or something like that. But so that's what, like, I don't think people should be trying to run this stuff in production yourself. You're taking too much headache or whatever. But you're still going to have like the question of like, well, how do I develop? How do I do CI and stuff like that? And that's where, K3S and those things, you'll picking it up, just to run it in those environments. But yeah, that's kind of my, my pitch or thought there. Cause I'm a big supporter. Like the way I look at this is like, I think the Kubernetes distribution is a complete commodity. It should be. Like any vendor right now who is trying to differentiate and tell you that like they have the best distribution of Kubernetes is like, it's nonsense. It really is. Like Kubernetes distributions are a commodity. You should just be able to get it anywhere. But there's an obvious gap of, if I'm not running in the cloud, how do I do data center? How do I do edge? And then so right now, that's what, Rancher as a business, we solve those things. We have RKE, we have K3S, we have whatever. We're giving you a distribution. But the point is, we're giving you a complete commodity. It's like, this should be a no-brainer. You get this thing installed and it's running, right? So anyways, that's, so it's just pick the technology that makes sense for the target environment. So,
Right.
Yeah.
And there's very interesting discussion going on Twitter as well. I was seeing yesterday or maybe 2 days back, it started like building Kubernetes from grounds up. And
Right, yeah, that was an interesting thing. Yeah, and because I've tried that a couple times and I've done different things there of like, and And I've really come to appreciate, because, if you've followed me on Twitter for a while or whatever, the one thing I'll see is, like, I have not been very favorable or very nice to Kubernetes over the years. I've been very critical. I'm kind of a stubborn, because I just want things to be simple, and Kubernetes is nowhere simple. And so most of the work, and I think that, why people appreciate what we've done at Rancher is we really try to make it simple, but it is an incredibly complex task. But over the years, I've kind of grown to appreciate what Kubernetes is and kind of its role, and that it is one of the reasons why it is so popular and has such an amazing ecosystem, has to do with the fact that it's not opinionated. It is kind of everything to everyone, so everyone can kind of use it in a different way. But that does make it more complex, and it doesn't make it user friendly. Like the creating great user experience is not a goal of Kubernetes, and I don't think it should be. And it's as much as, because I've been very vocal and complaining about how difficult Kubernetes is to use, and then all the upstream people who work on Kubernetes, they've been like, well, how can we improve this? How can we make this better? And as much as I complain, kind of the answer is, well, you can't and you shouldn't. Just leave Kubernetes as kind of this more raw platform, and let other projects build on top of it and put an opinion on it. Because the only reason why something like K3S can exist is because if you don't agree with our opinion, you can find a different distribution that has a different opinion, and you can pick that up. So it's like I'm able to make certain choices and make it easier for a certain use case, because you still have other options on how to get Kubernetes other ways. So it doesn't make sense for the core Kubernetes to get significantly better. And so this is where it's like people are like, well, I'm going to rewrite Kubernetes and make it better or whatever. It's like, well, it's fundamentally, it contradicts the nature of what Kubernetes is and why it's successful. Is like, because you can't take this like generic thing and try to tailor it to a certain use case. You will immediately make it not as appealing. And so what I've always appreciated about Kubernetes is the only thing, like Kubernetes, the only objective is it just needs to be technically correct. And because kind of its history of coming from Google, and all those people are so smart, have a lot of experience, they know what they're doing, they produce something that is technically correct. And it is difficult, and it is hard to use, and all those other things. But it's an amazing platform that I think is going to be around for next decade or so. I mean, I definitely think this is not just a little like, I really hope Kubernetes goes down to this layer that most people do not touch it and care about it, but this technology is going to be there for a while. It is definitely, it is a very transformative thing. It's going to change kind of the landscape of how we look at infrastructure. But I hope less people touch it.
Yeah. Building on top of Kubernetes will be, something that people should be focusing on, and not touching the Kubernetes as itself.
Yeah. And the way the ecosystem has evolved, and it's like engineers love new shiny things, and so Kubernetes was a new shiny thing, and everyone wanted to touch it and use it. And as a result, it's kind of like people were not as accepting of abstraction layers on top of it, because they're like, no, Kubernetes needs to solve my problems, not your thing on top of it. But we're now getting to the point where it's like people realize, like, it's becoming more of a commodity. It's becoming a lot more boring or whatever. And they're more accepting of like, well, now we can start building more tailored solutions on top of it, where you're not directly interacting with Kubernetes anymore. Yeah.
Right. So moving on, next thing that we have is Fleet. So Fleet is something that I would like Darren to speak upon, and if possible show some demo to the people who are watching. So what is Fleet, and why it is there for the GitOps at scale, and how we can see it. So I'll stop the sharing, and if you want to share and show something, all yours.
Yeah, I'll try to. This is where I'll miserably fail on something. So let me just kind of let's see. Let me pull open a new window here. Let me see if I can just share. Select. Okay, you should be seeing a blank terminal here. And sorry, I have a mechanical keyboard, so you're going to hear me typing, which is terrible. Oh, and it's right next to the microphone. Oh, that's terrible. I'll try to type lightly. I don't think it's possible. So Fleet, this is an open source project. So it's here. The GitHub is Rancher Fleet. So what this is, like where this project came from was it came from a very kind of obvious use case for us, was that as K3S got more and more popular on the edge, then question is like, well, how do I manage a bunch of Kubernetes? Like, how do I manage all these K3S instances? Because we're in the data center or, cloud data center environments, people right now, like some of our larger customers right now are closer to 1,000 clusters. When we were looking at K3S, most of the projects were starting at 1,000 clusters and going more towards 10,000 or above. And so how you manage that becomes a little bit different. Right now, within kind of enterprise, clusters are a little bit more like a pet these days. You spin up a cluster and it's dedicated to a team and it has specific configuration and stuff like that. And like when we start looking at thousands and thousands of clusters running on the edge, we can't treat it in the same way. So Fleet really came from the idea of how do I manage a lot of clusters at the edge. Now, at the same time, GitOps was becoming more and more popular. I really think Weaveworks, they've done a lot to kind of pioneer that space and push it forward in the Kubernetes realm here. And so GitOps was getting a lot more popular. And so when we first built Fleet, it was actually just a engine on how to deploy. It was like an engine of how to basically synchronize state a bunch of clusters or whatever. And then as GitOps is getting popular, we realized, hey, Fleet, the underlying engine, aligns very well with GitOps. And so we kind of geared Fleet towards GitOps. And so it became this project of GitOps at scale. And the reason why I kind of introduced it that way is because the GitOps portion is actually very simple. It's like, you clone a repo, you get some state from it. The power of Fleet has much more to do with the underlying engine of how it kind of deploys and renders and manifests and stuff like that. But so the idea of Fleet is GitOps at scale. And so there's two different projects that I can kind of compare this to get an idea of what Fleet is and how it compares to GitOps or whatever, is that there's Flux and Argo out there today, which are really great projects. So Flux I think did a lot to pioneer the GitOps with Kubernetes approach or whatever. But Flux is oriented towards a single cluster and it is a pull model. So you run it in your cluster and it's pulling down Git resources and applying them to the cluster. Argo is different in that it's a push model where you run an Argo server, which will then communicate with Git, get information from Git, and then it will push it down to the clusters. And so Argo is capable of doing multi-cluster, and it is a push model. So Fleet, the way Fleet works is actually from the surface, looks very similar to Argo. So Fleet is run as a centralized thing. You register clusters to it, and then it will do GitOps to these clusters. But the reason why we didn't just go with Argo, because I think Argo is a very good tool, people have had a lot of success with it, is just the architecture did not work for what we were needing. We couldn't really scale that push model of how Argo works to thousands and thousands of clusters. Also, the clusters are going to be possibly disconnected. All these different things. So the end result is we ended up building Fleet, and Fleet uses what we say is like a two-stage pull architecture. It will first pull the state from Git. It then figures out where, what clusters need to be updated with what, information or whatever. And then all of the downstream clusters, they run an agent, which will then pull from the centralized Fleet controller or Fleet manager. I kind of say Fleet controller and Fleet manager interchangeably. So this model, it's actually a pretty simple architecture, but since it's using a pull, And the way the components are written, they don't need to be always connected. We can scale this thing really far. In fact, let me see if I can find it. I just recently did a blog about this. I don't even know where our own blog. Let's see. Enter.com blog. Oh, here we go. I just recently did this blog, which is scaling Fleet and Kubernetes to 1 million clusters. So Fleet, well, we actually tested it up to 1 million. And so the idea of why 1 million was that we wanted to just basically remove scale, like, because we know people aren't doing 1 million clusters right now, where projects right now are more in the 10,000, like 1 to 10,000 range of running K3S on the edge. But we wanted to just make sure that, we could prove that this thing scales. So we actually tested this up to 1 million. But one of the things that's really interesting about Fleet is the architecture that we used is that we didn't want to invent a whole new architecture. It's like the Kubernetes controller, the pattern, how it's written is like, we wanted to see if we could just take the standard Kubernetes approach of writing controllers and get that to scale. And so the Fleet, how Fleet is written is going back here is we have the centralized server. This is just running actually a Kubernetes controller. So this is a Kubernetes cluster running a Kubernetes controller. We have no specific API or anything beyond what is the Kubernetes API. So like Fleet is just a series of custom resources. And then down here in the clusters, they're running a cluster agent. The cluster agent itself is just another controller. It's a controller that is a little special in that it talks to 2 Kubernetes clusters. It has it watches the upstream Kubernetes cluster, a local one. But so the whole architecture of Fleet is just following the Kubernetes architecture. So when we said we wanted to scale it to 1 million, the reason why this blog is called Scaling Fleet and Kubernetes to 1 million was, can we actually get Kubernetes to manage, millions and millions of objects? Because if you look at the current scale of Kubernetes, you can do 5,000 nodes or whatever, but there's all these things of you can only have 10,000. I don't know. I can't remember. It's something like you can have 10,000 namespaces or whatever. It's all of the scale requirements for Kubernetes right now, you can see is well, you really have to have less than let's say 100,000 objects in there. And for us to scale to millions of clusters, we needed something closer to being able to manage 20 million objects. And that's kind of just the starting point. If you had more deployments and whatnot, it might go up. So we might go up to 100 million is how can we accomplish this? And so, read this blog. Well, it goes through all the details of how we did this and some of the things. But I'll tell you the biggest differentiate, the way that we really made this work is really Kine. It's using the Kine project. Is etcd the fundamentally can only handle it's just an internal constraint of it can only have about 8 gigabytes of data. And so, doing the math for 1 million clusters, we would need at least 6 gigabytes of data just to start off with. And so that already puts you, above a reasonable size. And that's not even, that was there's a bunch of other things. It's the 6 gigabytes is nowhere near, because when we look at the way etcd works, is you only have so much data, but that data includes every revision of the object that is yet to be compacted. And so it's very easy to get into a situation if you're thrashing etcd where you only have, let's say 200 megabytes of data in there, but you fill up the default 5 gigabyte key space because of just the thrashing. So anyway, so there was just no technical feasibility of how we could do that. So we ended up by using Kine, we were able to scale, and I wouldn't say this ran fabulously well at 1 million. There's, you can read the kind of the outcomes of how it's, it takes a long time to start up and stuff like that, and things are out. But anyways, this is kind of going a little bit into the weeds or whatnot. But so the whole point of this is that the scalability of Fleet is intended to be very, very high. And the architecture works so we can have clusters that are fully disconnected and everything. So I could demo this. So sorry, how long does this stream go towards? How much time do we have left?
We have, there's no limit for
We'll
this,
just keep
so
going.
we can do the demo.
Okay, so what I'll do.
That's what conference, so we want people to understand basically, and this was the exact explanation that I was looking for. Like, what exactly Fleet is and what's the base target for it when we have Argo and Flux. So I think it explains a lot of things and how simple the architecture looks like, but beneath that, it's doing running controllers and doing the polls. So that's pretty interesting. And the million story I would recommend everybody to read. I mean, it's I mean, when you think of like running a million of million clusters, so that itself is that thinking itself takes a courage to think that you will be doing a million things. So read that. I think that would be more insightful and might lead to more innovations in future.
Yeah, and also I want to point out, like, the way we did the million is that that's actually vertically scaling, because we're looking at like federated models and whatnot because of other networking constraints and data security type things that we're looking at different federated models that will effectively get us to just infinite scale. I mean, because we're really looking at, it's like, as I was saying, it's like Kubernetes, I think is just it's here to stay, because when you look at it, it's like we have the cloud, and that's exploding, and so many people are moving to the cloud, and I think Kubernetes will be very, very relevant in the cloud space, and then it's doing very well in the data center space. But now that K3S, how we've put that there and we've made it very viable, and it's still very early, and there's rough edges. It's like it's not smooth sailing. I'll tell you, there's still things we're working on, but like, it is very clear, it is technically feasible to run K3S on the edge. And like, the amount of projects we have, I mean, every single type, this is like, I think this is funny, it's like every single type of like moving object or moving vehicle, like planes, automobiles, submarines, space stations, whatever, like, people are putting K3S on. Like, I'm excited. I can't remember what the project was, but we finally had the first public project that I could point to. I can't remember what it is, where K3S is going to space. Because there's quite a few, actually, I'm aware of. I just can't talk of them, of projects where people are putting K3S in space. But anyway, so it's like we've now kind of proved. So it's like now you have this like common a way to interact with infrastructure, no matter where it is. Like, we're really, this is where I get excited about, kind of where Rancher's heading and stuff like that. Is that we've had these different pillars of like cloud, data center, and then edge is this newer thing, but even like, it's not as new as you would think, because when we talk about edge, it's a lot of like retail, factory, places where there's already computers. They're just really bad at managing them, to be honest. Like, they just need easier way to manage them. But we're now able to create this like very consistent approach of how you interact with all of this. And like, it's going to explode. And like, because we have one approach of how to basically tackle everything. And it's really exciting to me, because that's always been the goal of Rancher from the very beginning. What we've always wanted to do with Rancher was that we had this idea of like, how do we build the overlay cloud? We want a cloud that spans, it's like, how do I make it so it doesn't matter what cloud you're running on or whatever? Like, I can, have the same approach to running everywhere. And at the time we started the company, we were so narrowly focused on just basically like cloud and hybrid, those type of deployments, that we never even considered edge. And now the edge is opened up into this new thing. It like now makes the story, it makes total sense of why we would have kind of this common kind of platform to run over all of this. But anyways, that's going quick. So I can demo this a little bit, but I kind of want, so the way Fleet is packaged is it's just a Helm chart. So it's very easy. You just need to have Helm. And then you're basically, I don't think that's up to date. What's the latest version? Oh no, 3.1 is the latest release. Let me just double check if there's not a, yeah, we're about to do 3.2. But basically, to install Fleet is really, it's just installing a Helm chart. We separate the CRDs into a separate chart. That's a whole different discussion of managing CRDs with Helm. But anyway, so it's just a Helm chart. You install that, and then if you're just doing like a single local cluster, you're using GitOps to manage the local cluster, you can actually just right away just start, deploy a resource and get going. It's super simple, and that's GitOps for just a single cluster. So if you're just doing a single cluster, Fleet will actually work perfectly fine. It works well in kind of like the local use case. But if you want to go towards larger, like the multi-cluster and larger scale or whatever, then that's where you're going to want to go into the docs here. And so in here in the operator guide, this is the whole process of how you run cluster registrations. And so to register clusters is really you need to create a token. And then once you have the token, you can then install the clusters using, it's then just a Helm chart. So the agent itself is a Helm chart. The manager is a Helm chart. Okay. So this is how you use Fleet, kind of a standalone project. And the way we architected this is we specifically wanted Fleet to be its own project by itself. It's not tied to anything in Rancher. Like there's no specific tie-in to any other Rancher project. You can just use Fleet by itself. And we specifically did this because we would like to, as this continues to evolve and get usage and whatnot, is we do very much want to push this project to CNCF. We don't want this to be just a Rancher project. And so it's kept as its own component. So it's pretty easy to use. It's not very difficult. But it's a couple steps, and you need to read through those documents. And it's very Kubernetes. You need to know Kubernetes and Helm and those things to get going. What I'd actually prefer to demo is actually the integration into Rancher. So in Rancher 2.5 is we now include Fleet directly into Rancher 2.5, and it's a component that's just kind of always there. Because even if like Fleet itself does not take off, like this project for whatever reason is not successful, we have a very strong use case of using Fleet within Rancher of when you look at it like this GitOps at scale. If, as I mentioned before, there's this fairly complex engine that's running to actually deploy everything. If you remove the Git integration portion, it's actually just a very sophisticated multi-cluster manager that scales. It's a scalable multi-cluster manager. And so what Rancher does, our main product of managing multiple clusters, it aligns very well. So Fleet has always been written from the perspective that it will end up being the replacement engine for how we manage everything in Rancher. And so the first step of that you see is in Rancher 2.5. And so what I want to do is, this is going to be a little awkward to a certain degree. Well, we'll see, because let me share my, oops, hold on.
And meanwhile, I have also posted a link in the chat for everyone, a Rancher 2.5 quick intro. So I did a quick intro for that. It's less than 10 minutes, so you can just watch the 2.5 features. It includes the Fleet and some of the high-level overview if you're just new to Rancher, like what it does. So you can just have a look at that as well. Just a quick intro.
Yeah. So let me okay. So let's see what for some reason. Oh, that's the wrong one. So that's sharing. That's my ngrok screen. So we're not gonna share that one. Well, no, actually, I can just do it on this one too. Okay. Well, did that get? Can you see that? Did that get bigger?
Yeah.
Okay. Let me. I'll try to make that a little bigger. So see. Okay. So what I'll do here is basically there's a lot of different ways to run Rancher. Rancher, you can just deploy it as a Helm chart on any Kubernetes cluster, or there's a very simple Docker container. So this is actually usually the easiest way to get it up and running very quick for like development or demo or whatever. But you'll most likely want to deploy it as a Helm chart on Kubernetes, and so there's docs and whatnot for that. But oops, sorry, need the privilege flag. Sorry about the typing. Yeah, so to get Rancher up and running, like we'll just run it through this Docker container so you can see it. And I am going to be doing. I've got ngrok running here. I always run ngrok so I can get access to my
Local.
cluster so I can deploy things out in the cloud or whatnot.
How many local
So,
clusters you have, by the way, just out of curiosity?
sorry, so what was that?
How
What?
many local clusters, local Kubernetes clusters you are running?
Oh, well, I typically, because I'm always doing like multi-cluster development and whatnot, is I typically run about like 5 different clusters. I've shut everything down now because of the screen share. But yeah, so I typically run about 5 different clusters, and they're all running K3S, and I use K3D extensively. K3D is amazing. But actually, like I have this kind of this repo that I test with some stuff. Let me go back and share my screen here. Oops. Here it is. I test stuff with. Oh wait, no. It's I build cloud kitchen sync. No. I think it's called repos. There you go. Fleet kitchen sync. don't run this unless you have a lot of memory. But this deploys. It uses, like I set up one cluster and then it uses the cluster to then deploy a bunch of other clusters. So I run K3S inside of little pods. I have this little like fun project here. This is not like a production grade thing. This is why it's just in my own repo here called K3S operator, where you can create a K3S CRD and it will just create a pod that has K3S. So like you can very easily spin up K3S clusters, and it's just for development. There's no persistence or anything like that. That's why I haven't pushed this as like a public thing. But I use this so I use GitOps to basically spin up a bunch of K3S clusters, which then automatically get registered with the main one, and then I deploy software on top of it. And so yeah, so it gives me like this nice kind of demo environment, so I can test a bunch of different multi-cluster stuff that I'm always doing or whatever. But okay, so let me go so this is let's see. Yeah. This is the Rancher UI. So Rancher in 2.5. So we've added this thing, continuous delivery. So this is the fleet integration. And let me see when it first comes up. Yeah. So this makes it super simple of like, basically I've got my clusters, I've got my cluster groups, and then I've got my Git repos here. So, so the really cool thing about this is like, this kind of dawned on me as I started using, like, as I have a lot of fun with GitOps because I think GitOps is super cool, is you can look at this as like, well, I can register, like the whole idea is like, I create a Git repo. So I'm going to use this one demo from, this is our lead of our field engineering team, wherever they use this to demo fleet or whatever. So I'm going to use this demo here of like this. What this has in it is well, here, before I get into this, let me explain a little bit about. So the whole idea of GitOps, if you're not familiar with GitOps or whatever, is like basically you keep the state of what you want to have, like your desired state of what you want to deploy. You keep that in Git, and then something picks up that state and deploys it into production, and then keeps it in sync. And so if you want to change something, you just go into Git, you modify the resources there, and then that will deploy into production. So you do everything through Git, and so you can do PRs and whatnot to do approval flows, a very flexible approach. Yeah, so there's a bunch of examples in this repo. The documentation for Fleet will link to us of different approaches of how to put resources in there. So like the simplest approach of like, well, how do I deploy some Kubernetes YAML? Well, the simplest thing is just create a Git repo, put some YAML in there, and Fleet will find the YAML and it'll deploy it. It's like very straightforward, right? But then there's other things of like, well, how do I do? Sorry. How do I manage Helm charts? How do I do? So if I want to do a chart, how do I do that? So this is an example here of like, okay, well then just put the exploded contents of the chart here, put the values YAML, and then there's this Fleet YAML in here where you can kind of customize and do different things. So you can also deploy if you want something from Helm Or another thing is like, well, how do I deploy from customize? So there's 3 approaches we support, which is just like raw YAML. You just put YAML in a repo, or you use customize, or you use Helm. Those are the 3 like most popular approaches, and that's what we support. So here's examples of basically how to do that. But then the question is, okay, well, that's simple for if I just want to copy this to a single cluster. What if I want to copy it and deploy it to a lot of clusters? And so this is where you get into these multi-cluster examples of what you can do is you have basically like, this is the pure YAML approach. You have your base set of YAMLs, and then you can just create these overlay directories. And in here, you have like, this is like a small patch that you'd put on there. So you create these different overlay directories. And then going back here into this Fleet YAML, you can then say, okay, well, if my cluster selector matches that, then overlay this one. Or if this selector matches that, then overlay this directory. So the different overlays will put on top. So it's a very basic approach on just how to do things with raw YAML. No fancy technologies there.
This was bundle.yaml, right?
What?
Previous.
Yeah, it was previously the bundle
This was
YAML.
called
Yeah, so this Fleet YAML file is actually so if I go back to like, let me show like the simple example. This is like the bare bones. There's no Fleet YAML in here. So if you don't have a Fleet YAML, then like we just basically we look for certain things of like, if we can find a customization YAML or a chart YAML or just any YAML, then we just kind of detect what it is. But if you want to specifically customize the behavior, then you have this Fleet YAML, and this is all covered in basically. If you go here, expected repo structure, the documentation here will cover how, what you can put in there and how it works, and this is like the full reference of what can go in the Fleet YAML, and there's a lot of things of like. Customizing what's the default namespace or what's the target namespace, how customize works, how Helm works. You can actually have Helm go out to a remote repo and not pick up the resources that are in there. So there's like a million different ways you can slice and dice this or whatever. So it's very flexible, and then on top of it, this is where we get into the multi-cluster stuff. So let me explain like how the multi-cluster stuff works. So the idea is like, once I have a Git repo, but instead of just deploying that Git repo to a single cluster, I want to deploy it to multiple clusters. Then what I would do is you set up targets. When you register the Git repo, you set up targets and you say, okay, well, match these target repos. And then in the Fleet YAML, you can then say how it's going to be customized per target. So there's kind of 2 mappings. There's one is what clusters am I targeting for deployment, and then how do I customize things per deployment. And so in the Fleet YAML here, so you can, that's what these are, these target customizations is for, this set of clusters, and then I'm going to change it this way, or this way. And then so there's approaches of how you do that with Helm or customize. So for Helm, it's pretty straightforward. If you look in here, of basically in here, here's the cluster selector that's matching here, but you can just put the Helm values. Like this is the equivalent of what's in the values YAML. So if you're using Helm charts, it's really straightforward because you can say, okay, well, per target, just these are the different values that I'm gonna put in. But you can get even more complicated of like matching Helm with customize, where like here's an example of basically I'm going to pick up this chart from an external repository, but then I'm going to apply these customizations from customize. Anyway, so there's a lot to dig in there and use, but the whole idea is like you can do like customize this. So like a very common thing would be like, I want to deploy this application, but it goes to like to clusters that are in different regions. And therefore I want to set different like endpoint targets, in different areas or whatnot, or, just set like a region label or something like that. So let me try to actually demo this. Okay. So going back here, so I'm going to use this example here of this repo. I've never actually deployed this, so we'll see what happens when I deploy it. We'll just call it Chris demo. Okay, so when you add a repo, So this is under the hood. These are all just CRDs. So like I'm doing this through the GUI because it's really easy to demo this way. But like you can just do everything as CRDs if you want, and you can use Fleet to manage itself. So it's like you can actually use GitOps to manage the GitOps. You can get into arbitrary complex. But basically, you just say, okay, well, what do you want to watch? Do you want to watch a branch? So I can do master here, or whatever branch that I want, or you can do a specific revision. This is if you want to. Like instead of actually, watching for new updates, you fix it to a specific revision. So then when you update it in Git, you don't actually get the live deployment from Git. You would have to update this and change the revision. But some people are more conservative that way and want it very controlled. But branch is a common thing to do. We do support various authentication. Well, the main ones is SSH key or basic auth. So if you are running private repos, this will work. You just need to set up like in GitHub, just set up a deploy key, and then you can just put in the public key and the private key here. But here this is public. So the paths here is you can have a repo and you might have your content at some subdirectory within there, and you can actually have like multiple paths. Of like we're deploying multiple paths from there. But here I'm just going to do the root. So this is where it gets into the multi-cluster part. Is like, where do you want to deploy this Git repo to? Do you want it to go to all clusters? Or if I had some clusters, this drop down would actually say like have a cluster here. Or you can do advanced where you're doing like labels and whatnot. So I'm actually going to do the advanced one. Because I want to show you this because I think this is kind of cool. Match labels. Okay, so what we're going to do, let's see.
Basically, we can have different clusters with different labels. So say 10 clusters on dev and 10 clusters on stage, and we can have different labels on them, and we can deploy different set of apps depending on the environments to different set of clusters via this.
Yeah, so you can get in like pretty complex, like targeting specific clusters or targeting specific groups of clusters. But so this is like when you get to a larger scale. So what I'm going to do is we'll just say, okay, I'm going to make this so that it matches. We'll say like env prod. So let me remove all this. So this is going to create this Git repo. And it's going to deploy to this cluster selector, okay? So let me create this, and let me just look at the, sorry, no commit for, that's probably, wait, did I type this in wrong? Git updating. No commit for branch master. Oh, main. Shoot. Oh, man. That gets me. Okay. Sorry.
It's main now.
Yeah, everything is switched to default as main. So let me switch that to main. That makes more sense. Okay. Yeah. Okay. So that's clone. But you can see clusters ready is 0. Like I've added this repo because I don't actually have a cluster. So this is like kind of the cool thing that I've realized is that like, you can actually go through and it's like you can define your entire deployment, like everything that you want from Git, but you can register that and you don't actually have any infrastructure yet because you can decouple these things. Because like as I was saying before, it's like Kubernetes is a complete commodity, right? So you should just be able to like treat like Kubernetes is just a set of resources that I need to get from somewhere. So here I've defined everything. And so like the power of this is like, everything in Kubernetes you can define as a Kubernetes resource. So this is not just applications. This is also what's your policies, security. Like you can put everything in here. Like 100% of how your cluster is configured can be defined in Git. And so I can have like multiple repos. Like maybe this is just one application, but I can have other repos that are like common security things that come from the security team or whatever. But now, so you can define everything in Git. So it's like once I have the whole definition of everything, it's like, well, then I just need some resources. I need a cluster. And so what I'll do here now is I need a cluster now. So I'm running I run K3D all the time. So right now I have 2 clusters running, but I'm just going to use the default one. So I already have a cluster that's just running on my laptop through K3D, but I could just go, if I wanted to, in Rancher here. Well, heck, maybe I'll even do it because it does. Is I can just go here and say like, oh, let me just add a cluster from DigitalOcean. Here's a demo cluster. Darren. Sorry, I've got to add. Oops. Dio token. Wait, is that it? Dio token. Yeah, this should be good enough. STF. Anyways, this will take a little bit. I'm not going to use this. So like, I'll just show you. So it's like, if I wanted to, so like this will go in provision. It will take a couple minutes to provision this one. But in the meantime, what I'll do is I'll just import. I'll import this cluster from or I'll call this one K3D. This one comes from K3D. So this is how you import a cluster into Rancher. Okay, so just give it a second. It has to deploy an agent and whatnot. But you'll see here, this one is coming up. So the idea here is, so once these, so I'm using Rancher to manage my clusters. So sorry, going back to here, there's a million different ways to get clusters from Rancher. Amazon or like the cloud providers, or you can import it. You can deploy your own. There's a lot of different ways. So, but here I'm just going to import a cluster from my laptop, and then I'm also provisioning one out into the cloud here. I'll probably actually annihilate that cluster because I didn't make it very big. Let me, oops, not rotate certificate. Wonder if I should. Well, whatever. We'll deal with that later.
There's also a question from someone does the controller in Fleet also has high availability or deployed as standard?
Yeah, it's high available. Yeah, it's highly available because as I say, it's just a controller that runs on Kubernetes. So it's like the high availability of Fleet really has to do with the high availability of the Kubernetes cluster that's running underneath. So in Fleet can be deployed, that question there can be deployed on K3S. In fact, everything that I'm showing you here is running on K3S. Well, not this demo cluster. This one is running on our own distribution, RKE. But anyway, so this one here, so this cluster came in. So if I go back to my continuous delivery here, so you can see now, okay, it automatically registered that cluster. It says waiting to check. Oh, let me see if the give it a bet. It says it's waiting to check in, but that might be. I hope I set up like the ngrok right. Just give it a bit there, but you can see like this is not deployed. It's still not deployed to any cluster because when we set this up, when we look at the YAML here, like oops, that's all the state resource. Oh, sorry, it's up here. When we set up the target, it's going to map to a cluster that has to match this label. So when I bring in this cluster, it's not going to deploy to anything because this cluster doesn't do it. So what I can do is I can now just here say, okay, well, let me just add the label of prod env. And okay, so then once I do that, let's see.
But you have to create the cluster groups as well with that.
So it's not necessarily required to also have a cluster group, because when you do, you can select clusters and you can also select cluster groups. So it's like I can add this to a cluster group if I wanted to. So I can do here and say like this is my a group here, and then so I can say okay, this is prod. Oh wait, did I do this backwards? env is prod. I think I labeled it backwards. env is prod. That's what makes more sense. Okay. So I created this one. Yeah, okay. So you can see here, this still says there's 0 clusters because I labeled this one wrong. If we go back here and we say edges as YAML, you'll see, yeah, I did the label backwards. Okay. So anyways, the technology works as designed. So let me put the right label on here. It's supposed to be env prod, like that. And then you apply. Okay, so now at this point, it's not working. Wait, let me just refresh it.
I think the label there you put env. Can you check that for this?
Did I mess it up again?
No, for the group.
Oh, for the group? Okay,
Yeah.
env prod. And then for the cluster group, what did I put? Okay. Edit as YAML. env, man.
Yeah.
Okay, so this is like, I have like, if you ever watch like any talk that I've done or any presentation or whatever, I have like a 0% success rate. People make fun of me of like how bad I am at demoing things because I almost always fail. The best demo I ever did was for Rio. I demoed that at a DockerCon, and it was like I hooked up the monitor to my laptop, and it just straight up crashed the laptop. And then I couldn't get the laptop to reboot. And then like after I got it to finally reboot after a little bit, I couldn't get Rio to start again. So I'm like, okay, just imagine I'll type this command and this is what it should do. It was the worst demo I've ever done. Okay. So anyway, so now you can see here, okay, now it's doing, yeah, I don't know why this one's not checking in because I probably screwed up because it's from my laptop. I wonder if the second cluster will come in, and then we can probably use that one. But so now you can see here, it's like basically once I added that label, now it's in this cluster group because it added to the cluster group. But if I look at this Git repo, I should get the same thing too. By saying like, okay, now it's trying to deploy to that cluster. Okay. And if I go, oops, click the wrong thing. If I go here, you can actually see the status of all of these things. Like these are all the resources it's supposed to be deploying. And they're all right now in a wait applied situation because for whatever reason, this cluster is not actually checking in. Let me go back to the one that I deployed in DigitalOcean and see if that cluster, and it still hasn't quite deployed yet. It takes a couple of minutes to deploy things. Let's see if this one comes up because this one might be like just a dud because it's running a K3S on my laptop and whatnot. We can try to debug it real quick and figure out. So if I go to the Cluster Explorer here, because when we deploy, I'll show you. So this is the Cluster Explorer. If I go to the apps, so when we deploy, we get this fleet agent. Oh, shoot. Fleet agent. Oh, crap. This is an existing cluster. Oh, hold on. Let me just do this. Let me just wipe out that cluster because that's why it's not happy. Just give me a second because that was, I thought I had like a blink cluster, but that was a cluster that already had like Rancher and all this other stuff on it. Sorry, anyways, you can see the live debugging process of how I epically fail at this stuff. Let me see. Where is this going now? Yeah, network request failed. Let me see. So this is still happy, right? Okay, let me delete this one and we will re-register. Let me just add another one. You can't see it on another terminal. I just wiped out that cluster and created a new one. It literally takes me about like 15 seconds to get a new cluster because I use K3D. Like K3D is amazing. You should really check out that project. But let me, so we'll do this one again. K3D2. Okay. Create. Apply this one. Okay. Let's see. That should come up here in a second. Yep, it's creating that. Go back to cluster, as you can see. And this demo one, this one's almost available. It's coming. It's fully. There you go. It's updating.
Yeah, there's a question does Fleet has roadmap to add monitoring logging based solution?
Well, no. So I'll show you in this demo that I'm going to do here. It's basically it's going to deploy monitoring and logging and stuff like that. But like Fleet itself is just the the deployment engine. It's just doing like Git or whatever. So it's not it itself does not have monitoring logging, but it can help you deploy like Prometheus and Fluentd and stuff like that. So like as part of the Rancher project, we have like if I go here, let's see, let me go to Cluster Explorer. This is the new cluster that I
deploy the monitoring and logging solution from Rancher itself. So that is, I think, enough.
Yeah. So like we have like this is Rancher itself. So this is you can just do monitoring. Like you can just click here and deploy monitoring. And there's also logging, storage, a bunch of other little things. These are just all Helm charts. This demo that that we will eventually get deployed here is we'll actually deploy these things. Okay, so you can see now like I have these two clusters, but this one still says waiting to check in. I wonder if it's gonna ever deploy. But this one just came up, so just give it a second. K3D2 waiting check in. It just could be just a dud here. Anyways, okay, let me. This is a problem too, is I always end up using like development versions of all this stuff, but we'll see. We'll see how far it goes. Okay, so, oh, that's why. That was a bad idea. Okay, let me think about this. How can I easily fix this? Easy way to fix it. This is why it's not checking in. It's because the CA is wrong. I really want to demo this, so I don't want to. Okay. Just give me just one second. I know how I can fix this, but I'm gonna have to like wipe it out real quick. No, I don't want to. Sorry, people. Did they all? Let me see if the other one did the same thing. So this one, demo cluster, signed by an unknown authority. We can just fix this all in post. Sorry. Okay. I think this will go slightly better if I do it this way. Just give me just a second. Sorry, you can't see what I'm doing because I'm on a different window here. But I'm spinning up a completely different Rancher instance because that one I think I configured the CA wrong, like because I was going through ngrok and then it screwed up the CA certificate because I was trying to do it. I don't typically run it in that manner, but okay, this should be just give me a second here. I swear we can get back. Okay. Okay. Let me just. So I just wiped out that instance, but it should hopefully work right now. Okay. So what I'm going to do, I'm going to add back in the demo cluster. K3D3. We'll do this third time. I swear this is going to work. If it doesn't work, we'll just, at that point, we're just going to have to give up. Context. Okay, so that cluster is now importing, but at the same time, since I wiped everything out, I just need to re-register that Git repo. So give me a second to register the Git repo. Oops, not create from YAML. Sorry. Great. This is actually running like from master, like because I don't. This is how I always run things, because I'm always developing. Master, go back. This is main. We are going to deploy back to advanced. Oh, you can see like you can select this cluster if you want to go directly to that one, but I'm going to do the advanced. And we're saying env is prod. Okay, create. This is going to work this time. All right. And then we've got the cluster back. Please work. It says waiting to check in. Don't do the exact same error. Okay. Let's see. If this doesn't work, I'll be upset because I really want to demo this. Cluster check. Okay. Woohoo. All right. We are back. Sorry for that. That was a boring. Yeah, and you couldn't even see like what I was typing and stuff, so you can get to see all the fun like live demo or live crap. But anyways, okay, so we're back. We've got a cluster registered. We've got the Git repo, but again, I still don't have like the right label on it, so we are going to assign the label to it. So we assign the label, type in the right thing this time. So we say env prod. So now we can see that cluster. This one is automatically, it's trying to deploy. It already says air deployed. Why is it? Let's see. Oh, give it a second because this is like, I think, yeah, okay. So this is the reason why you're seeing this error is because this is like this is going to deploy like monitoring and logging and whatnot, and it's saying like, oh, the required CRDs are missing. So it's kind of like this is like one that's just splatting a bunch of things. So I think it should eventually reconcile. But you can see, okay, like this is in progress. This is updating. So this is deploying Loki and then our Rancher monitoring. So you can see all of these components are getting deployed. I don't know how long it's going to take this one. So like while we deploy this, because this might pull like a million things, let's set up also, we can just so you can see, we'll set up a simple one because this like a simple one, this should just deploy real quick. Okay, so so we'll do this. We'll get repo. So this is the simple one. Fleet examples, and then here in the path we're going to do simple. And here we just want to target. This is a development version. I don't know why the UI is weirdly gray like that. But we're just going to say we're just going to target directly to that cluster. And I'll show you what that actually does is when you target it directly to a cluster, edit YAML here, it actually just sets up a selector directly to the cluster name. Like this label is automatically already applied on this cluster here. Like this, yeah, cluster name, yeah, those things, whatever. So you can see, because under the hood, it still always uses selectors. So now you can see here, okay, so now it's deploying, oh, I spelled that wrong, but whatever. So it's deploying this simple one. So you can see here, it's deployed this, 3 of 6 resources are ready. And so these ones are ready, these ones are still updating. So updating, so it's pulling the images, it's deploying or whatever. But here from the cluster, I can get all the status of like, one of two repos are ready, these repos, like these ones, this stuff's happening. If you click on this, you'll see here's all the repos that are being deployed to this cluster. If you go on into the individual cluster, you can see, okay, well, here's the various resources that are getting deployed. Like this one is like very close to being happy. Oh, this is modified. I'll explain that in a second, what that is. That's probably done as part of just the demo. So you can see like this Git repo, actually, this is all happy and good. So if I actually have a group, group, and I say, okay, oops, don't do that again. env prod, okay. So then you get this aggregated status for the group too. So you can see like 100 for this cluster here. You can say, well, if I had multiple clusters, like I can register more and add them into this group if we want. But you get the aggregated status of all these things. So you can see, so this is how you can like start to getting to like thousands and millions of clusters, because once you get to a certain size, you're really going to start dealing with cluster groups, and you get this aggregated status here. So what's happening here, the reason why this says modified is I'll show you the Git repo. So if I go down, okay, it's like this. If I look in here, everything deployed fine, it's all ready, but this one's modified. So what we do in Fleet is when we deploy something, we deploy it, and then once it's there, we first make sure that it's in sync. So it's been deployed and it's been synchronized to the cluster. The next thing is we then monitor it after the fact for two simple things: has it been modified, or is it ready? So all of these ready, this is looking at the resources. So if I was to go and change something, let's go back to this one, the simple one. So this simple here. Okay, so let me see if I can make, well, here, just watch this screen. In theory, that screen should change. I'm gonna have to do this on a context, K3D cluster. What I'm going to do is I'm going to modify, what is this? Redis slave. I'm going to edit this one, and I'm going to change to the deployment, and I'm going to put it to, let me just change, first let's just try this. We'll put the replicas to 1. Okay, so you can see this one like right off. Like I modified like on another screen. Sorry, I wasn't sharing that screen or whatever. I just changed the replicas to 1. So this is live monitoring all this, because in this situation right now, the agent is connected. I have a live connection to the agent, and the agent is constantly monitoring all the resources down there. So it's like when something changes, it immediately detects it and then reports it back up. If this was in a situation where the agent was not always connected, it would report back up as soon as it can connect back into the central fleet. But you can see like immediately when I changed that, it said like this resource was modified. And in fact, if I actually go down into the YAML here, I'll probably have to refresh. Let me see. Here. Yeah. No. Yeah. In fact, if I even go down into the YAML here, you can see what was modified. So it was this one, this Redis slave. I changed it. This is the patch to make it so that it would be in sync again. So it's kind of the opposite of what you would expect. It's not telling you what changed. It's telling you what needs to happen to make it valid again. But it kind of points to the fact that something was changed on the replicas. Like this information, like we just put Fleet into Rancher in 2.5, like all this stuff will be bubbling up into the UI and significantly improving like what we've done in the UI. But anyway, so you can see, so if I go back here, so there's like at this point, it's like this one's been modified. What I can do is I can actually just say, well, force update it. And this should force it. Oh, shoot, that was the wrong one. Let me do this one. Let me force update this, because this one probably won't come back. But so this one, let's see if it brings it back. Yeah. Okay. So this one, give it a second. It's so I can actually just go in here and say like force update, and then it resyncs everything and it brings it right back. This one probably is. Oops, crap, wrong link. This one probably won't come back because if I look at this modified, this has to do with. I'll show you. There's like these really annoying. So there's situations where resources get modified after the fact in kind of like their normal behavior, like in like a normal situation. And so if I go here and I find modified. Okay, so you can see here what's been modified. Oh, it's this. Oh, this is actually because of XIP. Blah, 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 blah. Oh, it's this path type implementation specific, I bet you, is what has been changed. So what you can do in situations like this where like you deploy a resource and then for some reason it gets modified after the fact, but in fact the modification is acceptable and it's fine, then there is what you can do in the, I know there's an example in one of these, it's probably the monitoring. You can do this where it's like it's somewhat verbose or whatever, but you can say, okay, for this resource, effectively ignore any changes to this thing here. This is just a JSON patch expression here to basically remove any changes. So like this happens. So that's why this one is showing modified, is because after the fact that ingress is being modified by Kubernetes in a somewhat valid way. So when you run into these situations, what you want to do is first figure out if there's a way to change your source, the source YAML, so that it doesn't get modified after the fact, or if there's really no way around it, then you just put in a rule into the Fleet YAML to basically ignore that. But that's why that's coming up. But like what this thing did, I'll show you like this demo here. This demo here, even though it says it's modified. If I go back to cluster manager and I go and explore this cluster, I go to the apps, we'll see here that basically this thing deployed Loki, Rancher logging, which is Fluentd, and then Rancher monitoring, which is Prometheus. So all of these things are now like running on this cluster. So automatically I get, let's see, it's like all of this just came from Git. It's like automatically set up all this stuff. So it's like I got all these apps running. Let me see if I can find Prometheus, like workloads. Like where's default? So this example app, like this is grabbing CPU. Anyway, so it just set up all of this already for me, and then set up. This is all coming from the stone. Set up some logging and stuff to Loki. I wish I knew how to use Loki. I don't actually know, because I know Loki's in here somewhere. Let me see. Let's see if there's like I don't know how to get to it. Services.
Yeah, for people who are watching, I think you have got a very good idea of how what is actually Fleet and how it works. So basically, you have clusters. You can label them, or you can apply it to a specific clusters, or you can apply the same particular YAML files, helm, customize all the different options to all the clusters, or you can have cluster groups created based on labels, and you can deploy this particular Fleet, create separate of them, and deploy it to cluster groups as well. And even when a new cluster joins that cluster group with having that specific labels, so they also will be having the same thing deployed when they are attached. So they will be having the same application thousands of clusters that are coming in, and you have a specific set of app or a basic set of app that needs to be deployed. So you don't have to do anything, you just have a fleet created, and then everything gets deployed. So that's the basic power that you are getting, and it manages the state, it watches it across the clusters, and it has been tested up to 1 million.
Yeah, yeah. So that was a fairly haphazard demo. I hope you'll get like the basic idea of you kind of piece together back how this all works. I mean, it's extremely powerful, and it really greatly simplifies how you can manage kind of all this complexity of Kubernetes, of basically defining kind of all of your resources, put that all in Git, and then you just effectively have to provision clusters and label them properly to kind of align up the infrastructure with all the deployments.
Yeah, and that's super awesome, and it's super powerful with the and Rancher itself. So it's embedded in Rancher 2.5. So you get it out of the box. So I mean that is some that adds more easy way to do things that you can do with Rancher. So you can create clusters now. You can manage clusters at scale using Fleet and whatnot.
Yep.
So that's
All
super
right.
interesting. And so we have spent a lot of time discussing about Kubernetes distributions, K3s, a bit of microkits, K0s, and like all the history around K3s and different other side projects that Darren has been doing. And we went through Fleet, with all like where it originated, why it came into existence, where it is now as a standalone project, and with its tight integration, that is not the integration, I would say, just the Rancher offering that comes out of the box. Fleet comes out of the box with Rancher 2.5. So all these things are super helpful. I hope those who are watching and those who will be watching later gets a lot of insights, whether you are beginner, intermediate, expert, all levels. So I hope we covered something for each and every one of you. And with that, I think we'll close the stream. So thank you all for joining, and subscribe to the channel. Very close to 1K, and we have a lot of upcoming streams, and they'll also be exciting. Cannot promise it will be as exciting as this one, but yeah, we'll try to keep things going. And thank you, Darren, for joining. Just stay for a couple of minutes, and I'll end the broadcast for everyone else.
All right.
So thank you all. Bye. So Darren, you can say the bye to all.
Yep. Bye. Bye. Thanks for joining.